Okay, now on to tonight's lecture. You may have seen that beautiful poster that's out in front. The lecture is called Transformation. Our guest lecturer is Chuck Hoberman, who is sitting here in the front row, and he is the founder of Hoberman Associates, a multidisciplinary practice with clients ranging across a diverse spectrum and diverse sectors. His firm collaborates with architects throughout the world. It's an impressive list you can see on his bio. His projects are also diverse. His work is exhibited or has been exhibited in the Museum of Modern Art, and he is recipient of certainly one of the most prestigious prizes or awards by my estimation, the Chrysler Award for Innovation and Design, and I believe he won that in 1997. I also heard today, I believe that some of your work is on display at the CFA. So there is work down at the center on LaGuardia Place presently that all of you should go take a look at and pass on to your fellow students. And as most of you know, I'd rather have the time devoted to our lecturers, so I'd rather have you read the bio than reiterating it. But in the words, the first line of the bio, I take particular note, and I quote, "Nowhere do disciplines of art, architecture, and engineering fuse as seamlessly as in the work of Chuck Hoberman." And with that, I find it particularly interesting. Way back, he's past this now, he was also the inventor of toys. And I find it very interesting that two of our faculty, John Friedman and Tom Roshan, have brought in their toys. So I want to show you that architecture and design can cover many, many areas, and they're actually very beautiful, which also in some way go on to where Chuck Hoberman is right now in his profession, a very successful one and a needed one. So I, on that note, pass the lecture on to you. And after this, there'll be a reception and signing if you would like a poster.
Well, thank you, Judith, and thank you all for coming. It's a real pleasure to be here. The specialty of my practice is what I refer to as transformable design. And transformability in the sense of the way that I use it means the capacity for change, but in the sense of designed objects. And I'll just kind of briefly introduce some of the general principles of it and then show how we're applying them in the different projects that my practice is working on. So here's just a kind of a series of images of different projects that we've done over the years. And the idea is to design objects, products, structures that change their size and change their shape. And in many ways, that implies a functional change as well. And the idea is less about going from, say, state A to state B, as actually engaging with the process itself and really making that the subject. Really, the notion is that we shape change, and that really is our design medium, change itself. Now, this idea is something, the capacity for transformation is something that is rare in the designed world and yet is ubiquitous in nature, in particular among natural organisms, operating on the level of the changes in our body, the morphological changes, birth to death. We never stop changing. But also it's the capacity of how species change their form on an evolutionary timescale. And why do they change their form? Well, precisely to adapt to the environment. And to me, that's kind of the sort of the deeper resonance with this idea of transformable design, is that transformability is really all about the capacity to adapt. And adaptation, to me, at this point in kind of societal, the situation and history is really maybe one of the highest values that can be brought, the ability to adapt to changing circumstances. Now, our practice works over a variety of sectors and a variety of scales. We work from the scale of miniature medical instruments up to architectural scale. And the principles of transformable design, while adapted to these different scales, actually carry across in a number of different ways. But in many ways, this is a practice of an inventor. And I'm going to start with an invention, a kind of an idea that I had some 20 years ago or so, which is shown by this little linkage shown on the screen. And it's a scissor linkage which, as it folds and unfolds, has a particular property, and this animation will show you. So two straight links, scissor links crossing each other, get parallel lines going through their endpoints. And it was well known at the time I came up with the invention that if you move the connection point off-center, you get a changing angle, and there were kind of pop-up structures designed on that principle. And my discovery was that if you bend or angulate the links, that angle doesn't change. It becomes a kind of invariant in engineering terminology, thereby allowing you to connect others of its type and to make a folding ring, or indeed a folding sphere. So perfect lead-in. Thank you, Judith. This is the actual original prototypical piece of the sphere that was shown before, made up of the kind of venerable materials of cardboard and grommets. But it was basically a proof of principle, showed that the system worked. So I came up with this and basically began to make expanding spheres. Wouldn't try this at home. I made a toy, and as you've seen, and this is one of my favorite customers from Japan, and here are a few of our other customers over the years. So this was a very unusual experience to have, as a designer of a product where something that was kind of just grown in a, not to be a toy, but really as a sort of a pure piece of geometry, became, in effect, kind of a worldwide phenomenon. And, at the point, I sort of thought, hey, this is really, it's not so difficult. You kind of come up with an idea, you bring it into production, it just gets, it goes out there. But of course, what I didn't realize, and I realize all too well now, is that phenomena like that really it's like lightning in a bottle. It happens, but very, very rarely. But it was certainly, very exciting. Toys notwithstanding, the principles of transformable design are quite methodical and rigorous, and I know that there are many designers among you, maybe most of you are, so I'll just go through kind of a few of the broad principles of how I and my team work with this idea of transformability. So one way to think about it is start with a solid object. Let's say we start with a plane, and if you imagine a series of hinge lines put into that, then this previously solid surface can fold up to a small bundle, or a circle can be treated as a kind of a folding wheel, or a box can collapse. And in this sort of conceptual formulation, you start with something solid, you break it into pieces, you connect those pieces with mechanical joints, and the previously solid shape now has transformability, the capacity to change and transform. Another principle that we work with is the idea of behavior, and in many ways, what I do and what my group does is think about designing behavior. Behavior in the sense that an object itself has an inherent way of acting or performing, and one way of seeing that, by concrete example, is an expanding sphere. All points move outwards in straight line trajectories from a center, and expanding shapes made on the same principle, in the case of the spiral on the right, also have that quality. So this performance, this behavior, emerges from geometric organization. And this shows a larger structure based on that spiral, which is a 40-foot high sculpture at Discovery World in Milwaukee in a spiral staircase, so-called helicoid. So we're kind of exploiting that property of this expanding shape to fit in with a fixed architecture. One way to think about transformable structures is to realize that they actually inhabit a kind of an in-between zone between structure and mechanism. So a structure classically defined is an assemblage of pieces that resists forces. But a mechanism takes those same forces and flows them into a particular motion. And a transformable structure basically acts in both modes, but at different times. So sometimes it acts as a very solid object, sometimes it moves and transforms. And one of the key questions and one of the key goals is to make it do the right thing at the right time, to be solid when you want it to be solid, to transform when you want it to transform. So my practice is very engaged with building big transformable structures. And if you go to a structural engineer and you may say, like, well, how do I ensure that, say, a building is safe, is secure, is stable? They'll say, well, keep the deflections to a minimum. But a transformable structure, the deflections are actually the equivalent of its size or its span. So you need a different concept of what stability means. Stability is process, so that you achieve safety and security, but it's done in the context of something that can move and transform. Now, there's obviously a lot of technology involved with this. I'm a degreed mechanical engineer, and pretty much everyone on our staff, with a couple of exceptions, are engineers as well. But sometimes I think that the value of this idea of transformability is less in the technology piece and more in how we think about design. So if I look at a list of words that maybe as an architect I might be quite interested in designing a building, if I simply put a modifier, transformable, in front of it, somehow it evokes a different meaning, it evokes a different image. And I think that that's very much how we as a group are introducing this idea into the world as a kind of a catalyst for thinking of new solutions, so that we have our own particular way of approaching it, but somehow the idea of thinking about change as an actual design attribute is very interesting, just in terms of how that leads to creativity and innovation. This is a sort of a concrete example of how we worked with a major tent manufacturer, Johnson Outdoors, to make a rapidly deployable military tent. This is a tent of about 700 square feet that goes up, this is about 5 times speed, but it goes up in about 3 minutes, or half the size of the nearest competitive project. So we actually, the way we work with a client like Johnson Outdoors is, my group is essentially the transformability experts, the transformability engineers. They are the tent experts. They're the experts in their market and their application. We join together to create a new type of product. And this is a line of military tents and tents for crisis relief that's out on the market now. It shows the same tent during wind and rain tested to, it's basically as a military piece. It has to meet all the requirements, up to 10 pounds of snow load, et cetera. So it's a very, it's a serious endeavor with, a lot of commercial importance to our client. We work on a whole range of projects, but this is one that is sort of reaching towards an architectural program. This is a retractable dome that we did for the World's Fair in Hanover in the year 2000, powered by hydraulics. And the program, such as it was, or the brief, was to basically create a symbolic representation of the historic Frauenkirche Dresden, shown on the right, and show that at the World's Fair. So the cathedral, which had been destroyed during the firebombing of Dresden, was being reconstructed, and basically at the World's Fair they wanted a representation of this resurrection of the cathedral. It's about 20 feet across. Materials are aluminum. And then our sort of largest built piece to date was the curtain that we did for the Winter Olympics in Salt Lake City in 2002, which was shown at Medals Plaza, where they gave the medals out. That's 72 feet across. This shows the working curtain at the when it was set up on the stage. So this is going into Salt Lake City, sub-freezing temperatures, high wind loads, great deal of structural performance required of a piece like this. The materials are aluminum. The panels are each roughly the size of a sheet of plywood, aluminum extrusions with a polycarbonate backing called lumicite. And you can kind of see the level of mechanical detail involved. And then this shows the same curtain integrated with lighting, and it was shown as it was basically a piece of a theatrical set. Every evening when they gave the medals out, they would open this. There was music and dance. They would open to reveal the flame of the Olympics. This is a terribly, it was a very exciting project, a real high point, certainly in my career, to participate in something like this. So now we're up to 2002, and, I was building quite large structures, building sized essentially, outdoors, dealing with, a lot of the functional requirements of buildings, or at least pieces of buildings, but they, weren't buildings. And that should be transformability in buildings, or transformable buildings. That's a slight typo. But the ambition, if you will, personal and of the practice, was to introduce this into real architecture and not simply into these sort of kind of tangentially related fields. So what had changed at that point relative to kind of the 90s? Well, one thing is that suddenly, sustainability was becoming an absolutely critical factor. And I'll introduce a couple of facts, which I'm sure many of you are familiar with, relative to what buildings are doing in the environment today. So by many estimations, buildings are the lead contributor to carbon emissions and energy usage. There are different ways to sort of parse that out, but in effect, you have this buildings as a type are actually more important to carbon emissions than our industry and transport, which is normally what we think of. So they may contribute 40% of the total, but in a city like New York, they may contribute 70 or 80%. And the question is, what are we doing to change the way buildings function? And one answer would be, well, let's just get rid of, if we have to lower our carbon usage, we'll just knock out half the buildings, but that's not practical. We have to find new ways of having buildings use less energy. One important distinction to make is between the operational energy of a building, that's its ongoing energy usage, versus the embodied energy in terms of producing the building itself. And what I had basically begun to realize in concert with a lot of the sort of friends and colleagues who I was speaking to was that the notion of transformability was indeed a strategy towards sustainable practice, was a strategy towards adaptation in the sense that, how buildings can adapt to the environment. Because buildings indeed are becoming more and more adaptive. We think of buildings as static, but are they really static? There's so many systems that are changing all the time within a building, and precisely in order to kind of manage the changing loads that the user puts on them and the changing environment as well. So, yet the view of buildings still is that buildings somehow become the static envelope between what clearly is the dynamic occupant of the building and the dynamic environment. So the conceptual work that I began to work on was how could this sort of these transformable strategies be applied towards adaptive strategies towards buildings. Now, this is I think is a trend that is not really unique to my practice. Buildings today are becoming more adaptive in many ways, and it's driven by these sort of macro trends. One is the sustainable imperative, but also because it's really the power of computation as well. So now computation is acting within architectural practice, both within the sort of design software with which we design buildings, within the manufacturing of buildings, and all the techniques by which mass customization can take place, and then within the sort of embedded intelligence within buildings themselves. So basically this trend is ongoing, and what I'm working with now is how to kind of use the special skills of transformable design towards extending that. Now, how might this sort of adaptive model work in, say, a building envelope or a facade? Well, if we look at the blue arrows, that might represent the environment, and maybe heat, light, moisture passing through an open facade. But the actual result that we want in the interior is represented by the orange arrows. So if we think about a series of apertures, some more open and some more closed, then when that same environmental parameter hits the building, some is reflected off, and you get the result that you're looking for. Another way to think about adaptive strategy in building is to consider it relative to energy use. So if we have, for example, a changing temperature in the environment, but the gray bar represents sort of the comfort zone within a building, how do we modify the interior of the building so that it's in the comfort zone? So one thing is that we do conventional forced air HVAC. We push the interior temperature where we want it. We burn fossil fuels to do that. There are, of course, alternatives. Passive strategies exist where there's really virtually no operational energy, although there's some embodied energy, to put in a passive system. But as a general matter, it's hard to get a passive system to work to get the building entirely within the comfort zone, especially when you're in a climate where the temperatures fluctuate dramatically. Now, the idea of an adaptive system is one where some energy is burned. Say that there's some like motors that are running to kind of change the configuration of the building, but once its configuration has been optimized for a particular environmental condition, it stops burning energy, and so you get lower energy use, but you start to approach higher performance of a conventional HVAC. Now, what I'm representing here is a kind of a little logic stream, which is basically the theory of where myself and the partners we're working with are pushing this idea of adaptive buildings, but the engineering validation and demonstration of this is really very much ongoing and in flux, and within the context of specific projects, which I'll talk about later. Now, if I am an architect or a client, an owner, and I say, well, what are my options for adaptive envelopes for buildings today, there are plenty that are available. This is not a new idea. We have shades or blinds or louvers, which we can put on a building. Those change in time to respond to the environment. But myself, as a designer, I look at these and I say, you know, I could go back 100 years and I could see shades and blinds and louvers. So what's happened in the meantime? Well, we've motorized them clearly. We've put computers on the motors, so there's a kind of intelligence. But in terms of the physical design themselves, it seems to me that it can, this is an area that really calls for advancement. And so this is showing a couple of the prototypical devices that my group has developed towards, it looks like a window, but I'm just calling it next generation louver technology, new ways of making responsive building envelopes. So we're working on this range of original, patented mechanical devices, but we also think of it in terms of how these devices can be customized for a particular building. So this shows a little demonstration applet of taking one of our devices where the user is basically manipulating this perimeter, and then the program is basically computing the shape so that you could actually design a trapezoid-shaped window like this. Then we've just added mullions and demonstrated its action. So that's one aspect of technology development relative to adaptive envelopes. Another area that we're working with is how these modular devices applied to the skin of the building can respond to the changing environment. And this shows another application relative to a project I'll talk about more later, which is indicating how when the sun tracks overhead, these shading devices are responding to the sun. And this will get clearer as we talk about it in the context of a project. The program that we're working with, sort of the very broad program that we're working with, is not to approach this from a kind of a purely a theoretical level, clearly, and not purely from a design level, and not even purely from an engineering level, but actually to take it the full range so that these can be, we can basically source these systems with industry today and deliver them on buildings. And to me, that's terribly important with any of these sort of, sustainability initiatives, is how is it actually going to happen in the field? Because there's a million great ideas out there, but somehow that has to work into the stream of built architecture. So we're working a lot with sourcing manufacturing as well. This is showing one of the shading devices that we've developed, a kind of hexagon that folds down to a kind of a slender linear bundle, and there's a sort of a level of industrial design going into this. This is a little demonstration video which shows how one of our systems, a so-called grid system, which is a series of perforated plates which can be translated relative to each other to make a kind of a window, is applied to a dome. And then the computer rendering now renders it more realistically. So you can see how these, with a greater number of stacked plates, how we get this sort of solid surface going to a filigree. And then as those individual panels are wrapped on or mapped onto the surface of the dome, how the dome can kind of transform. So we're building up from the unitized piece up to the full structure, which then is sort of rendered as a dynamic oculus with a transformable skin that surrounds it. So this creates a kind of a vision for a new way of thinking about architectural surface as a responsive field to the environment. But although it's really, in a way, this was done for a particular architectural competition, it's a rather sort of visionary scheme, and yet all of it is built up of rational engineering pieces aggregated together to make this, highly sort of advanced performative structure. This particular grid system is based on stacked perforated plates, and this shows that simply by cutting the individual plates with a different pattern, in this case an Islamic pattern, you can get a completely different ornamentation. So I'm always thinking in terms of how that sort of like intertwining of design and engineering, design and technology can take place, because ultimately our customers, our constituents, are designers. And I think that that's very much how I think about it. It's not actually I'm not an architect. It's not, the role that I see is still, in a sense, an engineering role, and yet we need new design possibilities to create this new level of adaptive architecture. This is another software application showing how one can work with three-dimensional form. So the user is adjusting the two curves on the left to create a doubly curved form, a so-called surface of translation, where one curve is translated along the other. That's broken into a series of slats which can be manipulated by this arm to make a kind of a retractable awning or canopy. Now, what's interesting is when you array that around that same surface, you get a somewhat more complex surface, which becomes a retractable covering that can extend and retract. Now, this is a kind of a sketch towards a full so-called parametric software application. It's not doing a lot of the sort of serious engineering things it needs to do with interference checking and all. But I think what it's giving is that sense that one can engage in developing these transformable structures in terms of sort of the classic ways of form exploration, form finding, et cetera, and then the software basically handles the technology piece. And this shows one scheme that was developed from this system, which is a very sort of a simple but quite a I think a refined form towards a shading canopy over a courtyard. Or in this case, another unit, which I'm calling an extensible surface, is a diamond shape that retracts to a linear bundle. And it kind of looks like it's rotating in the screen. It's not. It's a series of slats that are basically translating over each other within the plane. And this particular concept was then developed further for an exhibit last year where we participated in a design in the elastic mind curated by Paolo Antonelli at the Museum of Modern Art. And MoMA commissioned us to make a sculpture which we called Emergent Surface. So Emergent Surface consists of 24 of these retractable diamond surfaces, which are basically strung out over a series of 7 poles to make a doubly curved saddle surface form. And each one of these units can be individually controlled by a computer. So it's basically a kind of a surface that has sort of just infinite programmability in terms of which parts of it are solid and which parts of it are permeable. This shows another view of it. And the way that, when I've been lucky enough to get an opportunity like this, I really think about, going into the museum and integrating sort of our program of technology development, but also the communication, sort of a broader concept of adaptivity, within to kind of a broader public. Because I think that this is an area where, as people realize what these possibilities are, there's going to be more desire and acceptance to see them implemented. So for the remainder of the talk, I'll speak about a series of projects that we're working on with both architectural and otherwise, where we're starting to see the practical implementation of these ideas. Now, we've been working for a couple of years on several buildings with Norman Foster's office in London. And I'll go into some detail on this project, which is called City of Justice, which is a series of law courts in Madrid, Spain. And Foster came to us and basically asked us to look at, there's a large number of multi-story glazed atria, and they asked us to look at customized shading schemes for these spaces. So what's represented here in the colored regions is some 20,000 square feet of atrium space. And we were asked to kind of like come up with a very, sort of dynamic, adaptive shading scheme that really fit with, the Foster's design aesthetic within the building. So as we, sometimes do, we kind of came up with a metaphor. And in this case, the metaphor was of the tree where the leaves come out to shade us in the summertime and then go away in the wintertime to let the light through. And this is one of the kind of relatively early scheme animations where we had developed a hexagonal shade that basically can fold to a slender profile. And one of the design directives that the design team gave us is that they in effect one of these shades to kind of disappear within the structure and then reappear. So within the triangulated roof grid, our shades basically are kind of held within those structural profiles. And at the same time, what we were looking for was basically to kind of be true to that sort of metaphoric image of the tree with sunlight coming in, sort of dappled sunlight coming and making this, this shadow play on the floor. So this particular building is going into construction now. Our part of it is out for tender with a series of manufacturers that we've been working with to basically get preliminary pricing and make sure that we're working within the viable manufacturing systems of these four devices of this type with capable manufacturers. Now Madrid is essentially high desert, and you get a very intense sunlight coming in. So if you consider what adaptive shading means in a sort of a purely sort of a space sense relative to alternatives, well, if you want to have the right environmental qualities of the space, of course you can have fixed shading. But fixed shading has its drawbacks. In the case of, say, a heavy frit on the glass, you do reduce the sunlight, but you get a kind of a drab and flat space. What you can do with adaptive shading essentially is you can get that sparkling quality, you can get that vibrancy, but block the light where you want to block it and let the light through where you want to let it through. And in a sense, I think that that's really kind of creates this enormous architectural potential for how you work with light. Light becomes a kind of a sculpted medium that can really define what the space is. Another view of this particular building, which is called the Audiencia Provincial. In the development of these of our designs, we work with very heavily with so-called parametric software, so basically working with script-based software designed by algorithm, if you will, which is a snapshot from a screen from Inventor, which is one of the programs that we use, showing how sort of a two-dimensional profile is mapping onto the roof. In these kind of horseshoe-shaped spaces, our shades, basically we ended up with some dozen different shades, and the question was, each one of which is a fairly complex mechanical affair, and the question was how could we efficiently move through the design process to get to our full drawing package. And so the ability was to design one master shade and then basically have a series of databases where it could look up the different values and then modify each shade automatically to get all of the different profiles. That data is then fed into a series of data tables, which are then offered to the manufacturer so that basically it can go into their computerized manufacturing system. The process here, which is, frankly speaking, has been, we've learned a lot. It's been, we've had to experiment in terms of just how to work with all the different players. It's an open bid process. It's a public project in Spain. It has to be. And in fact, one of the things we've discovered is that it would be, in many ways, far more efficient to just start with the manufacturer from day one and really work with their systems. But in this case, we had to basically create a bid package that could be bid on by any number of manufacturers. So that actually created a great deal of sort of detail, which ultimately, a lot of which will have to be reproduced by the manufacturer when they build the piece itself. These systems are computerized, of course, and that is a whole other level of design, which is the control system for it. And this is a kind of a map showing the hierarchy of different control devices within and how they work from a communication standpoint between the different spaces. But from a performative aspect, one of the things that I found personally extremely stimulating was once you get this sort of remarkable adaptive system into the building, well, what does it do? It can do anything. I mean, you can program it to do anything, but what should it do? So what we did, working with the environmental analysts at Foster, was to kind of come up with what we thought was a sensible algorithm for how the shading system would perform. First off, we agreed that the light levels were going to be the main governing factor, as opposed to, say, thermal effects, which basically were taken into account once you had the light levels anyway. And what we found out, what we came up with was, in effect, it was kind of okay to let the light reach the floor to get that vibrancy and sparkle, but we didn't want it to reach the walls of the multi-story around the atrium, because that was where the offices are, and then basically they would heat up. So basically we came up with different cases of how we can get light to reach the floor, but not reach the walls. So sun tracking data exists all over the world, and basically using a software program, we basically fed the sun motion as it goes across across the arc, and you can see how the shades respond. So there's basically, those sequences were generated for every day of the year with numeric output for that. And then what you can see here is a kind of a simulation of the effect. This is if all the shades are retracted, and you can just see as the sun goes by, you sort of sweep across the floor, and you can imagine that if somebody was like in that space while the sun is beating down, it's going to get super hot. But when the shades are in action, the sun now can reach the floor, but the shadows are on the walls. So basically we're using the software, this is done in Studio Max as a true simulation, this is a kind of a verification and a validation that indeed our program is correct. The reason I'm emphasizing this so much is that ultimately the success of a project like this is not just that the mechanics work, but that it actually performs the way we say it's going to perform, and that means we have to communicate absolutely crystal clear to the manufacturer who's ultimately warranting the system that they will program it the way we want to program it. So all of this is something that becomes, in effect, our design purview as much as the actual physical part. And this shows a rendering out of Foster's office of what the effect is like. A second building that we're working on as part of the same campus is a building of the federal courts. The other one is the provincial courts. This one has one atrium, which is sort of a trapezoid shape. This is a diagram showing how the kind of all the layers are working between the structure, between the glazing, the shading, and the electronic controls. This is actually an early animation scheme, which I throw in, although it's changed quite a bit, because I think it has a kind of a very interesting sort of aesthetic impact, which is that, as these shades move, in effect, they become like pixels on a screen, but they're pixels that are not, just working with, say, the normal media of light, but they're actually physically changing the permeability of the surface. And in that sense, I think that there's this sort of physicalization of data that happens in the environment, which I think is really pointing to, the kind of the merging of the physical and the digital, which I see happening kind of on so many levels, today. And this is one embodiment of that. And this is the depiction of the experience of the space. One thing I like about this animation is it doesn't actually show what we are building in the space. It only shows the effect of it. And so the shades, which are kind of from a percentage standpoint, are a very small amount of the cost of the building, and yet have a huge role to play in terms of creating this sort of indelible experience of what the space is. And this is very much, what attracted Foster's team to work with us, and really why I think the collaboration has been extremely successful. Another building that we're working on with Foster is in the Mideast, in Abu Dhabi. It's a project called Aldar Central Market. It's a mixed-use development with a big retail component, and basically it's based on the idea of kind of an updated version of the souk. There's a series of public squares where another one of our shading roofs is being implemented. This is some manufacturing details. And let's see, I guess this is actually showing a little bit of the breakdown. This is a unit that's about 4 meters square. It's actually quite large, showing the different components. But this is the kind of thing that, it's like it's all broken down into its pieces so that basically the fabricator understands exactly what they're building. This is actually an outdoor installation. And then another movie, so you see it responding to the sunlight. Now, from a design standpoint, a lot of what the Foster team was looking at was a lot of fixed shading and working very much with Islamic motifs within that. So we were looking at this as kind of being this sort of seamless extension of the fixed shading parts of the project, but one that basically is working both in terms of an environmental piece, but also creating a kind of a real destination within the retail space for people to look at. And this is also due for construction, I believe, in 2011. The building that we're working on now, which is kind of on the nearest term horizon in terms of construction, is an adaptive facade where basically we develop design, kind of a design up to kind of pretty much up to schematic. It's been taken over by the Japanese team since then for a building in Tokyo on Ginza. So the client is Pola, which is a Japanese cosmetics manufacturer. This is a showroom building. And it's a 14-story high building, and basically they came to us and had a double glazed facade and asked us to come up with a scheme for both a shading piece, but also one that would actually have this kind of like theatrical presence on Ginza, which is effectively, it's the closest equivalent might be sort of Fifth Avenue, but it's a very high-end retail district with a lot of all the buildings have a lot of flash. So we came up with a series of a very simple mechanical notion, which are basically shutters, which live between the double glazed facade. And the idea was to have this building that could go from like solid to filigree. This shows the actual mechanics of it. So these shutters basically extend and retract behind the mullions. And this has been even simplified further by the Japanese team, but in fact it's pretty much the same scheme. These are photos from a recent mock-up demonstration at the builder Takanaka in Tokyo from December, and it shows the lower row shows the lighting, which is going to be a big part of it. It's like every evening there'll be a kind of a big show on Ginza. They're all these buildings are basically trying to outdo each other. And one more animation. This is something I show because within the architect Koichi Yasuda from Yasuda Atelier and Nikken Sekai, which is a very large Japanese firm, which is the executive architect. So they had developed this extremely kind of spare, minimal form for the building. And when the adaptive piece is sort of fired in a more sort of irregular way, you get all of this variability within this very kind of like, rigorous geometry. And to me, that's also quite an interesting direction for building design today, which is rather than sort of parking so much cost in what sometimes is a very kind of profligate form, you can kind of keep the form very simple and then get, maybe put more of that into a kind of a more adaptive performance, but you can get a lot of interest and variability out of that as well. This is a little bit of a wild card project, but it's sort of too exciting not to talk about, so I'll throw it out there. We are currently engaged by the Naval Research Laboratory, which is an arm of the Navy, to build a satellite. And in fact, it will be a sphere, just like the toy sphere there, except rather than being about this big, it will grow to be 10 meters high, which is basically 3 stories high. And we were contacted by a scientist, Paul Bernhardt, who basically had seen the toy sphere and had an idea that if you had this very large 35-foot high lattice-work sphere in space, that it could act as a calibration target for a whole panoply of radar systems, which are kind of over all of the globes by many different countries. And doesn't matter. Basically, so that these radar systems, which are currently don't have a proper calibration target, could use a sphere, which always has the same aspect ratio, to basically test whether the signals that they're getting are in fact correct. I don't really understand the science, so that's fine. So you don't have to either. But suffice to say that he has put the idea out there and has basically tapped into a stream of funding. So we're building this object, which is kind of going to be kind of extraordinary, which grows from about this big to this enormous size. Now, the piece itself, the sphere itself, will weigh somewhere around 350 pounds. This means it's an absolute, it's gossamer, it's lightweight, it's a filigree, it hardly exists at all. And the real challenge is how do you get a structure like that to work? It will be launched from the space capsule, it will grow in space with the torsion springs, but how do you test it on the ground? And that's actually a lot of the challenge of this design. The geometry itself, this is just kind of a fun piece to show how this is the sort of core DNA, if you will, which then is basically aggregated around by arraying it around a series of axes to get this full sort of Bucky sphere. And we work very closely on this project and many others actually with, we work with different structural engineering firms, but our real closest partner is Bureau Happold, is a UK-based firm, but with a big New York presence as well. And there's a great deal of interplay between the mechanical design, which my group does, and the structural designers, and all of that is very much automated in terms of the design software and how that data then gets fed into the structural package and back and forth. Showing us another couple of images from the structural side. And this is one of the outputs from the structural testing. So the orange lines represent the deflected shape of the sphere. All of the blue shapes are basically the support conditions while we're testing it. Because it's just going to be so incredibly flexible, when we're testing it, it has to be supported at many, many, many different spots. So you can kind of see how it's sagging. That's much magnified, but it's actually quite a real issue to make sure that we don't overstress the sphere when we test it. And then this is another piece of output where the color coding is representing the kind of the utilization factor for the actual stresses within the members. So this is a lot of as we work on these projects, very often, there's a kind of a creative component that may only be a couple % of the overall project, and then there's just a great deal of like intensive engineering development on these projects. And I'll just end up here with just a few images, just to kind of like loosen it up a little bit. No particular order. This is a retractable roofed concept. Maybe it's a retractable roof over a lobby that, when it opens up, becomes an open-air concourse next to a building. This is a concept for a retractable roof that basically works on a kind of a rectilinear plan, a series of square structural umbrellas, or kind of more of a spiral canopy. So we develop these schemes all the time in relation to projects and potential projects. And this I'm just going to end with, which just happens to be my favorite, which is based on a logarithmic spiral. Good. So that's it for now, and any questions are welcome. Thanks.
Thank you very much. I have many questions. That's always a good sign. So I will defer first to our audience. Are there any questions? John, there's a mic. Yeah.
Thank you for what a fabulous show. It seems that most of the things that you presented emphasized some of the transformable some of the terms that became transformable rather than others, and many of them had to do with surfaces at this point. In other words, we looked at transformable roofs, transformable facades, and only a few things that were transformable volumes. And I'm wondering if you have any thoughts about the direction that those might take. Obviously, the naval satellite is the first, but I'm wondering what else you might be thinking about.
Yeah, I think that from an architectural standpoint, I think surface is the way to go, at least if you think about it from kind of the lowest hanging fruit relative to sustainable performance. The building envelope is the mediator between the inside and outside, and actually has enormous effect on a building's overall energy performance. So it really is it's kind of application driven. Conceptually, I find working with volumes quite as interesting as surfaces. But there is, there can be a relatively high cost as well. I mean, if you just look at sort of part count, if you really are making like a volume transform, you may end up with a lot more pieces than you can, in effect, play good tricks with the surface and get a lot more economy for that performance.
Other questions? Well, I'll ask my.
Thanks for a fascinating presentation. I wanted to say that first. I'm really just, I was really just quite blown away, and I feel like there are so many questions, I think, like Professor DeMaio or Dean DeMaio, this raises for me. But I will just ask two of them. My first question is this. Some people say that today we live in an age of amateurs and amateurism, that increasingly end users can kind of participate in innovating, at least where the world of software is concerned. And we have new tools out there like SketchUp that allow my 9-year-old nephew to have a stake in design and in architecture. And I was wondering whether you've observed a comparable trend in engineering. Can the amateur or even the architect have a stake in engineering in the kind of work that you do that he or she didn't have before because of some of the new software and new technologies that are available? My second question is where are the most exciting centers in the world right now in terms of inventing in terms of the work that you do, like where are the global centers in terms of innovation? That's the other question.
Those are both actually, they're relatively challenging questions, I must say. Well, the first one in terms of amateur engineering, no, I don't think that there is a similar phenomenon, say, that, you know, there's not a similar phenomenon to, well, now I can make a piece of media, a piece of music, a movie, a graphic piece, because I have these tools to assist me. The degree of, I mean, not to make it, this isn't, you know, it's not huge technology, but there is the degree of education, capital expenditure, experience, all of those things that come into play for developing work of this type. Now, that said, I think that maybe you can kind of extend the question a little bit to when, as this type of technology comes online, is how does the, you know, I'll stick to the architect for now as opposed to just like the lay public, how does the architect engage with it fruitfully? And I think that there's a kind of predicate for really the successful rollout of this kind of thing, which is that this innovation, for innovation to succeed in the building industry, in my estimation, and I'm kind of coming at it always as a bit of an outsider, but it happens because you know, multidisciplinary teams sit down together with a great deal of curiosity, openness, and willingness to forge a kind of a collective you know, solution to whatever the, you know, the program or the brief that's handed to them. And in that sense, the architect who can fruitfully sit and, I mean, in my mind, and I'm not really one, I'm sort of on thin ice in many ways, but I think that, sure, the architect, of course, it is the design leader. It has to be, someone has to lead the group. But in many ways, I think the architect is the one who can synthesize all of the different consultants who sit down together. And in that sense, it's like they need enough openness and understanding to kind of work with it, but you can't ask, you know, someone who doesn't have the technical background and education to really like work it up from scratch. And so, anyway, global centers. No, it's different. I mean, there's, you know, I work all around the world, and certainly it's always strikes me that, you know, there is a quality of architecture and design that's very local. You know, I mean, despite sort of the international media and all, you go to a city and it's suddenly, Japan has been an absolute revelation to me. I've been 4 times in the last little over a year, and the, you know, the level of architects and architecture that I'm discovering that, you know, none of us, I certainly never heard of, is, you know, it's absolutely astonishing, and yet it's, you know, it's really quite wonderful. But I think that, you know, there are many cities certainly that have, you know, a great deal to offer that way. I'd have to think more about sort of centers. I mean, there's so many pieces to sort of the network that, or, you know, that I work in and that I am actively developing. It certainly doesn't have a regional cast to it. And we work with, you know, there's great, you know, we work with great manufacturers, say in the Midwest, for example, and, you know, there's some fantastic West Coast, you know, firms. Certainly the engineering, we work with a lot of big engineering firms, which are highly, you know, highly global.
Yeah, it was a really, really fascinating and provocative talk, so I thank you, because I like things that make you think. But first of all, before I ask, I had 2 questions. But in terms of what Professor Vasugian just asked you, I'd actually ask the converse based on this about global. for me, when I first started going to Berlin for a variety of reasons, and I walk around Berlin and I see the ability and the usage of glass and the options of the Scandinavian Center where the whole exterior skin is a gigantic louver. I come back to the States and I'm always just so disappointed because I think we are so completely behind in modern technology. When I go, I mean, I've been to China, not Japan. Do you find that to be so, or do you have the same kind of reaction, or why is it that it seems so conservative here? Or you may disagree.
Well, I think it's where it is a moving target. From a purely architectural standpoint, I mean, my sort of very direct involvement sitting at the table for, really true architectural projects is relatively recent, so I don't have that whole timeline. So a lot of what I could offer would be things that I think many of us know already, which is like the builders are conservative, they don't want to take on a lot, there's a lot of liability concerns, the structure of how, the ownership takes place, a lot of developer buildings where they don't have a strong interest in the long-term performance, et cetera. That's one side of it. I'm hopeful that, we're going to see changes. I mean, I'm hopeful that, that this sustainability imperative will indeed force changes on the industry, maybe not ones that will be pleasant, but good ones where, I mean, it probably, I would like to see, say, the architectural profession to begin to just become, not, it's not just a question of taking on the responsibility of the sustainability aspect of buildings, but actually to be interested in it, to be curious about it, to say that it really is like, I think personally I started as a visual artist. I'm always my first take is how does something look, and I'm very interested in the aesthetic and conceptual aspect. But the subject of, the physics and the performance of a building is absolutely fascinating, so I'd like to see that happen, and I think that will help. I mean, vis-a-vis Europe, yeah, sure, the level of construction is of course, much more refined. There is, there's a kind of a notion that they're going to be looking for much longer time spans during which their building is, buildings will continue to be, to look good and to act well. I mean, another thing is, look, the States, we do a lot of things great. I wouldn't say, building construction is one of them, but we're pretty good in technology and software and entertainment and all that other stuff. So.
It interests me because there's an entrepreneurial sort of nature inherent in the culture of America and the founding of America, and
That's
yet
right.
in building, it becomes for me very interesting that I don't have the same kind of reaction. So I totally agree with you about, we do very well at certain things, and we have so many now constraints, it's almost hard to get certain things accomplished outside of the envelope. My other questions are two, and they're more specific things. In terms of your talk, where do you see, would you say that the Jean Nouvel Art Arab Center is the beginnings of this notion of transformability because of that whole facade that moves like a series of lenses, or do you put that in sort of a different kind of category?
No, I think the Nouvel's building was absolutely a kind of a very important first step along the way. It's a somewhat fraught example because it doesn't work. It doesn't work well, and I say that advisedly because it's more that I've seen it a number of times, but the data points that have come in, because there's always like you never know if you're getting the full story.
It must be mechanized.
It's mechanized, and certainly as a mechanical designer, I can look at it and say, well, it probably could have been done better. But as a concept towards transformable building, it seems like a very important example. But in a way, that's the problem, isn't it? Because it's too much of architecture is based on novelty, where once Nouvel does that, he's sort of inhabited that space. So why would another architect want to go there, especially with all the ensuing headaches? I mean, some do, but it's kind of like it's a cautionary note. But this is not about sort of novelty. It's about performance. I mean, I'm sensitive to the design aspects as well, and I think that is an important aspect of sustainability as a general proposition, but within buildings specifically, is if you don't get the design right, it's not going to be accepted, it's not going to be legible, it's not going to be part of, just that's sort of the basic, human experience that we want from our buildings. So we can't divorce design from it, but it's absolutely not about a sort of a conceptual move, let's make buildings dynamic. We don't need to make buildings dynamic, we need to make them perform.
Yeah, no, I
for
agree.
our
I mean,
needs.
given when it was done, the word sustainability wasn't necessarily part of our vocabulary, and though he says it had to do with sun shading and device, you wonder why all the walls are the same, because the building's orientation takes sun in different ways. But what I was trying to suggest is this notion of transformability and change conceptually was when I saw that building was the first time I started to think a wall could move.
That's right, yeah, yeah.
So I just was wondering where you put that in your topology.
I think it's a very important, it's an important example.
Other questions?
I have a question. This is a more technical question. We as design studio, we do this skin analysis and various type of research on this thing. And one of the challenge many of students face is when the skin is transformable or adaptive or performative skin, it seems like it always required 2 layers of skin. One skin being the permanent weather blocker, and the other one works as ornamental shade that actually working with the sun directions and so on. Have you ever challenged anyone asked you to design a skin, single layer of skin that actually performs as shading device as well as weather protective skin?
I mean, I get the general drift of the question. I mean, for the mechanized solutions that you're seeing, that I presented, clearly there are multiple layers. I guess I'll interpret it. Maybe I'm not sure if it was the intent of the question, but there are clearly non-mechanical directions that adaptive skins can take. Solid state would be one of them. There's so-called switchable glass or electrochromic glass, so it's providing a continuous surface, single layer, but then it changes its state to either block or dim. And that's under development, and there's, it's has some longer-term challenges in terms of getting into the price range that it needs to get into. But I think it is also fair to say that there's if you look at over a long time horizon, many of the kind of goals of adaptive performance may be met more and more by pure material solutions where, there really is some genuine sort of physics in terms of how a material can change and become, more, say, multifunctional as a single layer system, in your terminology. And I'm keen on that. I'm interested in it. I speak to certainly, a number of scientists who are working in that sort of general area of nanotechnology, et cetera. But in the near term, I think that there's a lot of value in making these sort of more mechanized solutions work.
I saw another question over here.
So following on what you just said about the idea of movement, and your buildings really are about movement, and movement requires energy, are you looking at, from a sustainability perspective, alternative forms of energy that can actually make produce this energy that's required to make these parts move?
Well, that's a very good direction, I think. One thing I'll just sort of bring up, which it might have been in my talk, but I'll just mention it, is that as a general sort of business strategy towards this developing sustainable technologies, I've formed a second company in partnership with the engineering company Bureau Happold. It's called the Adaptive Building Initiative. It's kind of been on, it's existed for about 8 or 9 months, but it's just becoming, we're just sort of rolling it out publicly now. So the sustainable performance is something that, you know, I take seriously and realize that it's not, you know, it takes a lot more depth and breadth to kind of find the solutions, you know, than simply to sort of offer up these sort of cool mechanical devices. Sorry, I just want to get that out. The other part that, as far as the, I think that actually it's actually a very sound idea to say have this movement occur with perhaps, you know, like a photovoltaic panel or whatever, not for energy generation, which has a whole other kind of economics to it that's still kind of getting resolved, but simply so that these devices potentially can become much more autonomous. The systems that we're putting in now have a central computer that's tied in with the building management system, but sort of the idea that you can just sort of make a device and maybe it has its onboard power generation through a photovoltaic and some sort of a logic built in or a wireless communication. It's a very powerful idea, you know, that it becomes much more decentralized. And that's, I think, a very, you know, there's a lot of merit to that.
We'll take 2 more questions. Maybe we would have a question from a student. There's one.
Oh, my question is, from your sculpture background, other than aesthetics, have you taken anything influential into your work now? Because
Have I taken what?
from your sculptural background, have you taken anything other than aesthetics and that source? Has it influenced your work nowadays?
That's interesting. Other than aesthetics. Well, I mean, briefly, quick story, which is I have a good friend and colleague from my alma mater, Cooper Union here, and at Cooper, I studied sculpture. My mentor there was actually Hans Hacke, the German conceptual artist, and I think that his advice to me at the time, but it was kind of general advice, was that basically that a lot of the values of an artist really could be at play in entirely different sort of sectors of society and different professions, that you could kind of bring an artist's sensibility and conceptual framework into these other realms. And so in that sense, absolutely, I think, you know, I've always been very much about sort of, I mean, I have my sort of specialty, my design specialty, but I'm also very interested in just how sort of a design specialty like that creates interesting combinations, not just in the work itself, but among the people that I work with. So I'd say that's a kind of, maybe there's a little bit of a conceptual art program that informs all of this as well.
We'll take one more question and then we'll go to the reception. There seems to be a question.
Is there a material exploration that corresponds to the mechanical transformation?
Can you speak up, please? I can't.
Exploration you've done.
Is there a material exploration?
You mentioned aluminum, and I wondered whether there was a corresponding exploration of different materials
Oh, yeah.
in the range of work you've shown today.
I would say that, you know, certainly, there's an aspiration, if you will, in the practice to become sort of more sophisticated, to become more savvy about different materials. We've done a lot of work with metals. It has always kind of been in our comfort zone, but certainly I'm, you know, I think there can be a lot of benefits to sort of marrying these transformable designs to a different range of materials. So we do explore them. I can say we explore them probably in a fairly conventional way, in the same way that, say, an architect may have a bunch of material samples and speak to different suppliers and all of that. But you know, I'm think that there's a great deal to go in that direction.
Before we call, that provokes one question that I think I'm surprised no one has asked, but do you build large-scale mock-ups in your office, or do you do anything like that off-site, or do you build models?
All of the above. It's where, you know, the culture of our office is very much hands-on, is building. We build small models, mock-ups, full-scale mock-ups. It really is, it's driven a lot by the project.
If
But
your office is a big warehouse, I've not been to. Is it
no, I mean, it's a kind of it's an open space down in Tribeca. It's, you know, it's big enough. We can't do very large pieces, and we don't have a great deal of fabrication capability, but we do a fair amount of just cruder mock-ups, and sometimes we assemble pieces that are given to us by manufacturers. But then once you get up to a certain scale, you're working with a fabricator off-site, and you know, that's a very important part of it as well.
Well, thank you very much. It's really fascinating. I want to thank you. Really wonderful and very, very provocative.
Pleasure.
And please join us for a reception.
Thank you.